going to start a very important topic, probability, with Krishna Gopal Singh sir, and he's I call him KG sir. We call him actually KG sir, and he's BTech from IIT Delhi, and in 2002 batch. And since then, he's involved in teaching IIT JEE students, and I call him a friend because he was senior in my school also, and kind of guru also, because always we keep on discussing scientific problems and mathematics. And probability will be very important for you. And this is a golden opportunity to start it from the scratch, from the very basic. He will start from fundamental theorem of counting, how all it started, and then he will take you to a level which is just parallel to what type of questions we are getting in NET, JAM, GATE, or JEST. And moreover that, you can ask any doubts, anything regarding probability to him. He is like, I would say, authority on probability. So I think you will enjoy the classes, and I'm also joining with you all guys. So over to KG sir.
Hello students. The first thing that I want to tell you that in this class we are going to start from very basic. So the whole idea that suppose I have to arrange electrons in some energy states, or whether I have to put marbles in a box in certain boxes, as far as probability or permutation combination is concerned, there is the same problem. Whether you're putting electrons in energy states or you're putting balls or marbles in a box, it's exactly the same problem. So how we are going to start it is basically we are going to start it from the very basic, which is basically the fundamental principle of counting. And then from there we'll talk about permutation, combination, and where we'll talk about the day-to-day life example. Okay, if I have a class and there are certain boys, certain girls, and I want to make a hockey team with 5 boys, 6 girls, and all those kind of a thing, which are basically the day-to-day basic school level problems. And then we will use those same concepts in solving problems of physics. So the way it will go is we'll do permutation combination, nothing to do with probability, and then we will start using those problems for making problems of probability, and then we'll go to the physics problems from the probability. So that's how we're going to do it. Okay. So fundamental principle of counting, I believe in just 2 words, or and. Okay, I have m ways of doing something, I have n ways of doing something, and if I have to do either this or that, then the idea is total number of ways of doing it is m plus n. And if I have m ways of doing something and n ways of doing something, the total number of ways of doing it is m into n. So I have 5 shirts and 4 t-shirts, and I have to put something on my front. What are the number of ways? So now they are related with the or. I can either put a shirt or a t-shirt, so the number of ways is 9. 5 shirts, 4. Now I will use shirt and pant together. So total number of ways are 5 into 4, 20. So that is the first word, or and. Obviously life will not be so simple. So what will have? I have 5 shirts and 3 t-shirts, 4 pants and 2 pairs of jeans. And now what is happening? Total number of ways of putting something on my trunk is 5 plus 3, 8. Jeans or pants, 6 ways, and therefore total number of ways is 48, which is basically 6 into 8. So that is how we are going to mix and match and or together. So I have either shirt or t-shirt, therefore a sum, either jeans or pants, therefore a sum, and then this and this, therefore 8 into 6. Okay, this is the first thing that we are going to learn. This thing leads to permutation. Permutation, as you know, is arrangement. So simplest of the example is I have 1, 2, 3, 4, 5. 5 digits and have to make a 3-digit number. What are total number of ways of doing it? Now, number is something which is an arrangement. A number 315 is different from 513. So these are the arrangement. Collection is combination. Arrangement is permutation. So since I have to arrange these things, what are the number of ways of forming this 3-digit number? I will ask whether repetition is allowed or not allowed. If repetition is allowed, what I'll do, I will write these 3 digits. The number of ways of choosing the first digit is 5. I can choose any digit from 1, 2, 3, 4, 5, and then another 5, then another 5. So total number of ways is 5Q. If I generalize it, if I have n objects, I have to place it at n places, the number of ways of n objects, and I have to place it at m places. The total number of ways, or r places is the right word, and the total number of ways n into n into n, which is n to the power of r, because I'll put it at r place. So what happens if repetition is not allowed? What is happening? I have 1, 2, 3, 4, 5. I have to make a 3-digit number, but repetition is not allowed. I can place 5 digits over here.
Sir,
Yeah,
Sir, voice is
voice break हो रही है.
voice break हो रही हो. So sorry. What can I do? Is it clear now?
yes, sir.
Still a little bit because
Recording start now.
एक सेकंड. ये नेट की प्रॉब्लम
नहीं है, तो यहाँ पे
नेट का पूरा
नेटवर्क तो है.
आई थिंक थोड़ा सा जब बोर्ड.
If repetition is not allowed, then what I'll do? I place one of these 5 letters, these 5 digits at the 100 place, then 4 digits at the next place, and then 3 digits at the last place. And that is where we get the formula of NPR. So if I have n objects and I have to arrange it at r places, the number of ways will be n into n minus 1, so on and so forth, which is n factorial upon n minus r. Now the issue is, the problem is never so simple. No one will ask to 5 digits and I have to place it at 3 places, these kind of a question. So we'll start having certain special cases. So I'll pick up 2 special cases for this class. The first thing is, I have 0, 1, 2, 3, 4, 5, and I have to make a 3-digit number without repetition, and then 3-digit number with the repetition. So when I'm making 3-digit number without repetition, dash, 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 write these 3 digits. Now the issue is that though I have 6 digits, I cannot put 0 over here. So number of options for 100 place becomes 5. Now, out of these 6 digits, I have already used 1 digit. So then 5 on the next place and 4 on the next place. So it is neither n to the power of m nor NPR. Here we have 5 into 5 into 4 ways. it will be about what 100 ways. And if 3 digit with repetition is allowed, I will dash dash dash. I can place 1, 2, 3, 4, 5. 5 digits at 100 place, not 0. 6 digit over here and 6 digit over here, because I can place 6 0 at 10th place or 1st place, but we can't place 0 at 100 place. So number of ways will be 36 into 5, 180, something like that. Okay, so this is one special case. Another good case that comes, and I just love it, is about bowling, which is basically my favorite topic, cricket. So the question goes something like this. I have 5 bowlers and I have to choose them to bowl 2 overs. So number of ways is, someone will tell me? Anyone?
7.
Number of ways will be?
5.
Good, 20. So it will be 5 into 4. Because what will happen? First bowler will have 5 options, next bowler will have 4 options. If I have to choose these 5 bowlers for a 3 over match, the number of options are, anyone?
600.
Hmm?
60. 60.
100.
I am getting 100, 80, 60. And the 60 is very interesting. This 100 is also very interesting. I'll tell you why. This 100 is 5 into 4 into 5, 80 is 5 into 4 into 4, and the 60 is 5 into 4 into 3. So basically, obviously, first over 5 options, second over 4 options. Now for the third over, we have how many options? That
4
depends on the rule of the cricket. We do not have 5 options because if first over was bowled by me, second over was bowled by Alok, then Alok cannot bowl the third over. Okay, so we do not have 5 bowlers at the third over stage. And this 3 is also very interesting. What you are saying that if I bowled the first over and Alok bowled the second over, then neither Alok nor me is allowed to bowl third over, which is obviously not wrong, which is obviously wrong, because now I can bowl the third over. So number of ways is 5 into 4 into 4, because first over 5 bowler, second over 4 bowler, third over. Repetition is allowed, but is not allowed. So 4 overs. The answer is 80. So depending upon the kind of problem, whether total repetition is allowed or partial repetition is allowed, can come into the picture, and that makes the problem slightly tricky. So over here we'll have 80 ways of choosing these 5 bowlers, choosing 3 bowlers for these from this set of 5 bowlers. Okay. Now let's come to some cases of special cases of permutation. So one of the most interesting problems is basically arranging letters or digits or objects, whatever. So suppose my name is Krishna, and if I have to arrange all the digits, all the alphabets of Krishna, then I have 1, 2, 3, 4, 5, 6, 7 objects, and I have to place it at 7 places. So number of ways is 7 factorial. It's a pretty simple thing. We have already done it. The problem starts coming when all the objects are not distinguishable. Some things are identical. So instead of Krishna, I choose something like Mayank. So the problem with Mayank is that it contains two A's. So obviously answer is not 6p6 because we have two A's. So there's a theorem that goes with it, that if I have n objects out of which K1 are of type 1, K2 are of type 2, and so on and so forth, Kr are of type R, the number of ways of arranging it is n factorial upon K1 factorial into K2 factorial up to Kr factorial. So number of ways of arranging Mayank is, I have 1, 2, 3, 4, 5, 6. 6 objects. So 6 factorial, out of which there are double A's. Therefore, I have 2 factorial and then 1 factorial, 1 factorial, 1 factorial, 1 factorial for other 4 digits. But I'm not writing 1 factorial because obviously that is 1 and division by 1 has no meaning. Okay. But instead of Mayank, suppose my word was something like A, B, 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 C, D, D. Then when I arrange this combination of alphabet, the number of ways will be 1, 2, 3, 4, 5, 6, 7, 8. So 8 factorial ways, out of which there are 2 objects of type 1. There are 2 A's, therefore divided by 2 factorial. There are 3 objects of type 2 divided by 3 factorial. There is only 1 object of type 3, so that's 1 factorial. And there are 2 objects of type 2, type 4, therefore 2 factorial. So number of ways of arranging double A triple B C double D is 8 factorial upon 2 factorial into 3 factorial into 2 factorial. Got it? Then
Yes, sir.
we get some problems around groups. Okay. So let me just make a case. Suppose I have a class of 6 boys and 4 girls. So first thing that we have to understand is if I have a class of 6 boys and 4 girls, then these are 10 different objects. Okay. Obviously, when I am saying boys and girls, I am making two groups of these 10 people, but these are 10 different objects because boy 1 is different from boy 2, different from boy 3, different from boy 6. So if I have to have 10 chairs and I have to make all these students sit on these chairs, then total number of ways will be simply 10 factorial, total ways. Because as far as this question is concerned, for me, boys and girls are not different. For me, they are just 10 objects. Now, suppose I take a special case. I want boys to sit together and girls to sit together. Now in this case, what is happening? I have 2 objects, boy group and a girl group, which can be arranged by 2 factorial ways. So either I can sit all the boys over here and girls over here, or girls over here, boys over here. Now, within this boy group, I can arrange these 6 boys in 6 factorial ways. And within this girl group, I can arrange these girls in 4 factorial ways. The total number of ways is 2 factorial into 6 factorial. Why into? Because we are doing it simultaneously. And So 2 factorial into 6 factorial into 4. Okay, so this is one of the questions. We can just, by slight change of language, I can change the question. Suppose I want boys to sit together, but girls can sit anywhere. So just remove this group. Now I have a boys group. Put it like this only. So I have a boys group, but girls can sit anywhere. So my number of objects is, boy group is one group, G1, G2, G3, G4. So I have 5 objects, a group of boys and 4 girls, which can be arranged in 5 factorial ways, and then I can arrange boys among themselves, which will be done with 6 factorial. Okay. Similarly, if I want girls to sit together, but boys can sit anywhere, then we'll have a group of girls and B1 to B6, 6 boys. So total number of objects is, what is the total number of objects?
7.
Can you answer?
7.
7.
It is 7. That goes 7 factorial of arranging these 7 objects, and then within these 7 objects, I can rearrange girls in this girl group, which can be done by 4 factorial ways. And since I'm doing them together, it's related with and, the number of ways is 7 factorial into 4 factorial. Okay. Now, third interesting case comes. I do not want these 4 girls to sit together. What I'll do? First, I will in this case, what I'll do? I'll first place these 6 boys. So I can place these 6 boys in 6 factorial ways. Now, once I've decided how I'll make these 6 boys sit, I can put remaining 4 chairs out on this 7 position. Because obviously girl can sit in front of boy, she can sit end of the table or somewhere in between. So I have these 7 places, and I can put these 4 girls in any of these 7 places. So number of ways will be 7 P4, and the total number of ways will be 6 factorial into 7 factorial by 3 factorial. Okay. These are the sum of the cases of arrangement. Obviously, we will try more problems when we'll be doing probability, because obviously probability you'll have to arrange things. But I'll just give you one simple question. The whole idea is, suppose if I ask you that I have a group of 6 boys and 4 girls, and what is the probability that girls do not sit together? So basically, probability of an event is, as you know, number of event space upon number of sample spaces. So these are 2 questions. In how many ways I can make these 10 students sit on these 10 chairs? The answer is 10 factorial. And in how many ways these 4 girls will not be together? And answer to this question is 6 boys can arrange in 6 factorial ways, and 7 girls will be arranged in 7 P4 ways, which is 6 factorial into 7 factorial by 3 factorial whole upon 10 factorial. So in a sense, this question of probability is not a question of probability. These are just 2 questions of permutation and combination. So we are just doing this first class on permutation and combination, but will keep on taking these kind of problems when we will be discussing problems on probability. Okay, does that make sense?
Yes,
Good.
sir.
So with this, we more or less cover the standard ways of arranging things. There is one question which was asked in previous year questions, and it's about how to arrange words in dictionary. And I just want to take that one example. So I have a word like Sachin. I'm choosing Sachin because that was the question in one of the net papers. And if I arrange all the permutations of Sachin, then what will be the position of Sachin in those arrangements? If I arrange them like we arrange it in a dictionary, what will be the position of Sachin? It's a very simple question, but since it's a lengthy question, people get bogged down with that fact. So the idea is pretty simple. These are 1, 2, 3, 4, 5, 6. 6 letter word. In dictionary, we will start with A. Now, since we're starting with A, we will have large number of words starting with A. And what will be that large number? Anyone? Anyone?
2 factorial into 5.
Sorry, not what you're saying?
2 factorial into 5 factorial.
No, not 2 factors. Once I have decided that I will put A on the beginning, I have to put 5 more letters and PHIN. So I have 5 ways over here, 4 ways over here, 3 ways over here, 2 ways over here, 1 way over here. So the total number of ways is 5 factorial. Essentially, what is happening? Once I have placed A on the first place, I have 5 digits and I have to put those 5 digits. So this is 5 factorial. Then after A, we will have another C, and all the words starting with C will be having 5 factorial. 5 factorial is 5 into 4 into 3. 120, so 120, 120. Now we have already made 240 words. Then we will start word with I. Another 5 factorial, another 120 word, then I, another 5 factorial, another 120, then N, another 5 factorial, N. So basically, the first letter with N, S will start after 600 words. That's the now. Things will get difficult if Sachin is somewhere down the line. The question that they chose in net is Sachin because Sachin, if you look at it, ACHIN are in alphabetical order. So Sachin is first word starting with S. So what will be the position of Sachin? It will be 601. So they can choose a word which is somewhere in between the S, but the way they chose the question in the previous year net examination was something which is easy to calculate. Obviously, it's a multiple choice question and they want people to do it quickly.
Sir, एक बार question दोबारा समझा दीजिए और उसका approach जो है.
So Alok is asking that should I explain the question again? So मेरे पास एक word है Sachin. इसे मुझे डिक्शनरी में अरेंज करना है. I have to arrange it as it different permutation of Sachin will be arranged in dictionary. So मेरे पास 6 letters हैं. वो जो 6 letter के various combination है वो कहां से स्टार्ट होंगे? A से स्टार्ट होंगे. A से स्टार्ट होने वाले टोटल कितने वर्ड होंगे? तो ऑब्वियसली मैं A से स्टार्ट कर रहा हूं तो फर्स्ट प्लेस पे तो A ही रखूंगा. सचिन में से A मैंने ऑलरेडी यूज कर लिया. नाउ आई एम लेफ्ट विद 5 letters and I have to arrange them at 5 places. Therefore number of ways is 5 factorial. A से स्टार्ट होने वाले 120 वर्ड हो गए. अब जैसे A से स्टार्ट होने वाले वर्ड 120 हैं, A के बाद C आएगा उसके 120 वर्ड होंगे, H आएगा उसके 120 वर्ड होंगे, I के 120 वर्ड होंगे, N के 120 वर्ड होंगे. तो एस से पहले 120, 120, 120, 120, 120 को ऐड करेंगे तो 600 वर्ड आ गए। अभी क्या हो रहा है, ACHIN सब खत्म हो गया, अब S स्टार्ट हो। अब S से भी 120 वर्ड होंगे, और जो उन्होंने मुझे वर्ड दिया होता अगर वो कहीं बीच में होता, then there was a big problem because then I have to count it again and again and again. But the word that they gave us in the paper is Sachin. और सचिन की ब्यूटी क्या है कि S से स्टार्ट होने वाला पहला वर्ड, बिकॉज S के बाद ACHIN आर ऑलरेडी इन अल्फाबेटिकल ऑर्डर। इसका मतलब ये 601st पोजीशन पर उस डिक्शनरी के अरेंजमेंट में सचिन आ जाएगा। गुड
सर लास्ट थिंग ये चीज नहीं आ रही समझ, 60S का जो आ रहा है 60।
समझते हैं, A से 120 वर्ड होंगे, समझ में आया?
यस सर, दैट इज ओके।
फिर C से 120 वर्ड होंगे, समझ में आया? H से 120, सेम लॉजिक से। S से पहले डिक्शनरी में कितने वर्ड आ जाएंगे? 600। ये बात समझ में आई?
यस यस यस।
अच्छा, तो अगर S से पहले 600 वर्ड हो गए तो अब S से शुरू करते हैं। S से स्टार्ट होने वाला पहला वर्ड कौन सा होगा? S के बाद वो अल्फाबेट रखो जो सबसे छोटा है। तो ACHIN में पहला वर्ड कौन सा आएगा? A आएगा, ठीक है?
यस सर।
अच्छा, ऐसे आ गए। अब CHIN में सबसे छोटा कौन सा है? सबसे पहले कौन आ रहा है? C आ रहा है।
ओके यस
फिर
सर यस।
H आ रहा है, फिर I आ रहा है, N आ रहा है। तो अगर मेरा वर्ड मान लो होता SHCNIA, तो इसको कैलकुलेट करना बहुत मुश्किल होगा, बिकॉज वो 600 से लेकर 601 से लेके 720 S से स्टार्ट होने वाले टोटल वर्ड भी 120 होंगे। तो टोटल लेटर्स कितने हैं? 6 फैक्टोरियल विच इज 720। तो ये जो आंसर है मेरा वो 600 से बड़ा और 720 से छोटा कोई नंबर हुआ है तो मुझे क्लियर है। लेकिन अब SHCNIA कहां लाई करेगा, उसके लिए मुझे क्या करना पड़ेगा? पहले SA के सारे वर्ड देखने पड़ेंगे, फिर उसके बाद SC के सारे वर्ड देखने पड़ेंगे, फिर तब कहीं SH के वर्ड आएंगे, और उस SH के वर्ड में CNIA कहां, ऐसे बहुत लंबे केसेस बन जाएंगे ना। जनरली हम ये एज्यूम करते हैं कि एग्जाम में इस तरह के क्वेश्चन नहीं पूछे जाएंगे, बिकॉज देन obviously that will require a lot of calculation. If the question is something like Sachin, which is not very deep in between, S का पहला ही वर्ड है, then the whole problem becomes very easy और हम लोग उसको आगे, ठीक है? Good. So अब हम लोग more or less basic जो implementation ideas we have finished with that. अब we'll start with a bit of combination. टाइम कितना हो रहा है?
तो सर अब आज के लिए थोड़ा, क्योंकि ये हैवी हो गया, बच्चे इसको रिवाइज भी करेंगे।
अच्छा,
किसी को कोई डाउट है तो वो,
किसी कोई डाउट हो तो पूछ सकता है, कोई क्वेश्चन हो तो पूछ सकता है, बिकॉज आप लोग का कहना है कि हैवी हो गया है, हम लोग को रोक देते हैं। सॉरी फॉर दैट, अगर ज्यादा मैंने हैवी कर दिया हो तो। हाँ, किसी कोई डाउट है?
सचिन का जो आपने अभी बोला ना, उसमें
हाँ।
मतलब सचिन डिक्शनरी में कितना मतलब कौन सी पोजीशन पे आएगा वो क्वेश्चन जरा एक बार प्लीज बताएं।
आई थिंक वो डिक्शनरी वाली चीज मिस कर रहे हैं कि डिक्शनरी में शब्द कैसे
डिक्शनरी में वर्ड कैसे है? डिक्शनरी पता नहीं, आई एम नॉट श्योर तुम लोग में से कितने लोगों ने डिक्शनरी देखी है, दैट इज अनदर प्रॉब्लम। पर डिक्शनरी में मान लो सपोज करो कुछ वर्ड ले लेते हैं, वर्ड तो क्या है, कुछ नाम ले लेते हैं। मान लो मेरा नाम है कृष्णा, कोई वर्ड ले लेते हैं आलोक, कोई वर्ड लेते हैं अक्षत, ठीक है? अब कोई और वर्ड ले लेते हैं इसी तरीके से आकांक्षा। जब हम लोग उनको डिक्शनरी में अरेंज करना शुरू करते हैं तो हम सबसे पहले कहेंगे यार ए के सारे वर्ड एक साथ रखें, ठीक है?
यस सर।
ए के वर्ड में आलोक अक्षत आकांक्षा 3 आ गए, तो हम देखेंगे आलोक और अक्षत में ए के पहले है, ए एल पहले है, तो जे के एल का मतलब है ए के पहले, तो पहले आकांक्षा और अक्षत आलोक कृष्णा से पहले आ जाएंगे। और फिर आकांक्षा और अक्षत में मैं फिर सवाल पूछूंगा कि ए के ए पहले है, ए के एस पहले है, तो सबसे पहले मैं आकांक्षा, उसके बाद अक्षत का नाम लिखूंगा, उसके बाद आलोक का नाम लिखूंगा, बिकॉज ये तीनों ए से स्टार्ट हो रहे हैं। तो एके में पहले आकांक्षा फिर अक्षत, एके के बाद एल, और एल के बाद कोई बी से नाम होता, और फिर ऐसे बी के सारे नामों के बाद सी से नाम होता, और कहीं बहुत नीचे जाकर के कृष्णा है। ठीक है, इसी तरीके से जब मैं सचिन के अल्फाबेट्स को अरेंज कर रहा हूं, तो सबसे पहले ACHINS सबसे पहला ये होगा। क्यों? बिकॉज सचिन में सबसे छोटा अल्फाबेट ए है, देन सी, देन एच, देन आई, देन एन, देन एस। फिर उसके बाद क्या हुआ? ACHI को सेम रख करके एस और एन को आपस में पलट दिया। पर इस तरीके से काउंट करने लगेंगे तो 720 बार काउंट करना पड़ेगा। तो लाइफ में बहुत प्रॉब्लम है। हमने कहा इतना नहीं काउंट करना। ए के जितने भी केसेस हैं इनको सबको मिला करके मैंने सीधे कह दिया कि भाई ए के बाद 5 ऑब्जेक्ट हैं, 5 प्लेसेस पे रखने हैं, तो और ऑब्वियसली रिपीटिशन अलाउड नहीं है, इसलिए 5 फैक्टोरियल। तो ए के वर्ड हमने अलग अलग काउंट नहीं किए, टोटल काउंट करिए कितने हो गए? 120। ठीक है, अब ऐसे ही ए के बाद सी के वर्ड आएंगे जो कि फिर 120 हो गए, फिर सी के बाद एच के वर्ड आएंगे जो फिर से 120 हो गए, आई वाले 120 हो गए, एन वाले 120 हो गए। ये सारे जुड़ करके 600 वर्ड आ गए। उसके बाद एस के वर्ड आएंगे जिसमें सचिन सबसे पहला वर्ड है, इसलिए उसकी जो पोजीशन हो गई वो 601 हो गई। ठीक,
हाँ सर, अभी क्लियर है।
और कुछ?
सर आपने जो स्टार्टिंग में केसेस बताए थे ना, विद रेपिटेशन एंड विदाउट रेपिटेशन, वो जो 2 केस एक्सप्लेन किए थे, प्लीज उसे एक बार प्लीज रिपीट कर दीजिए।
कैसे रिपीट कर लेते हैं? मुझे 1 2 3 छोटा सा नंबर ले लेते हैं, 4, ये 4 डिजिट नंबर हैं और 2 डिजिट के नंबर बनाने हैं। तो मैं यहाँ पे 1 रखूं तो 1 2 1 3 1 4, 2 रखूं तो 2 1 2 2, सॉरी गड़बड़ कर दिया मैं, विदाउट रिपीटेशन वाला बना लगा। अगर रिपीटेशन अलाउड है तो 1 1 1 2 1 3 1 4 2 1 2 2 2 3 2 4 3 1 3 2 3 3 3 4, और ऐसे 4 1 4 2 4 3 4 4, ऐसे 16 वर्ड। बट ऐसे तो गिनना बहुत मुश्किल हो जाएगा ना। इसने कहा मेरे पास 2 प्लेसेस हैं, यहाँ पर इन चारों में से किसी एक को रख सकते हैं, चाहे 1 रख लो, चाहे 2 रख लो, चाहे 3 रख लो, 4 रख लो, और जब इनमें से चारों में से किसी और को रख दिया तो दूसरे पेज पे क्या कौन सा डिजिट रख सकते हैं? तो विचार तरीके हैं, और इसलिए टोटल नंबर ऑफ वेज 16 हो गए। सिंपल, कोई दिक्कत?
यस सर, नो सर।
लेकिन अगर रेपिटेशन नहीं अलाउड होता तो यहाँ पे तो 4 डिजिट रखते, लेकिन यहाँ पे 4 नहीं रख सकते, बिकॉज ऑब्वियसली जो डिजिट हमने यूज कर ली है वो तो गई है। तो मेरा ये 1 1 हट जाता है, ये 2 हट जाता है, 3 3 हट जाता है, 4 4 हट जाता है। ठीक है, तो 1 के साथ खाली 3 डिजिट, 2 के साथ खाली 3 डिजिट, 3 के साथ 3 डिजिट और 4 के साथ 3 डिजिट। तो पहले प्लेस पे 4 चीजें 1 2 3 4, और उसके बाद हर किसी के लिए 3 ही चीजें, इसलिए टोटल नंबर ऑफ वेज 16 से घट करके 12 हो गए। ठीक है,
यस सर।
और अगर मान लो कोई क्वेश्चन पूछ ले कितने वेज हैं जिसमें मोर देन 1 डिजिट, एटलीस्ट सम डिजिट इज रिपीटेड, तो इन दोनों को सब्ट्रैक्ट कर देंगे, 4 हो जाएंगे। ठीक है,
ओके
अब
सर।
इसी चीज को अगर 3 डिजिट पे करना होता, मैं 3 प्लेसेस बनाता, पहली जगह पे 4 डिजिट 4 डिजिट 4 डिजिट, तो 4 क्यूब विच इज 64 तरीके हो गए, विद रिपीटेशन 3 डिजिट नंबर 1 2 3 4 बनाने। और पहली प्लेस पे 4 ऑप्शन, क्योंकि उसको यूज कर लिया है, इसने नेक्स्ट प्लेस पे 3 ऑप्शन, और क्योंकि 2 को यूज कर लिया है, इसने नेक्स्ट प्लेस पे 2 ऑप्शन। तो टोटल नंबर ऑफ वेज कितने हो गए? 4 into 3 into 2 24 वेज हो गए, जिनमें कोई भी रिपीटेशन अलाउड नहीं। और ऑब्वियसली दोनों में सब्ट्रैक्ट कर दें तो 40 वेज हो गए, जिनमें एटलीस्ट 1 डिजिट इज रिपीटेड। ठीक है, इस तरीके से प्रॉब्लम है।
ओके सर, क्लियर सर। थैंक
और
यू।
बोलो। गुड, तो और लगता है प्रॉब्लम नहीं है, तो अब इसको यहीं पे रोकते हैं
सर
कॉम्बिनेशन वाली बात, और फिर वहां से प्रोबेबिलिटी वाली बात, विल स्टार्ट विद द नेक्स्ट वन. ओके, थैंक यू.
Thank you, sir.
थैंक यू सर.
Thank you, sir.
Thank you, sir.